Hi, my name is Mrs. Gaudette, and I will be working with you today on 3rd, 4th, and 5th grade math. So we're going to start you out with some routines that you can do at home with a parent or someone older, an adult. And this is just something that you can get the actual pieces off of our website to help you with this. But again, I'm going to take you through this. I am going to ask you some questions. Would like you to answer back to me before I give the answer. And then you can then repeat this with other people as well. All right, so we're going to start with our 3 sequence. I have this up here. So what I'd like you to do is, as we point to it, I'd like you to say the sequence with me. All right, here we go. We're going to say it forward a couple times, then we'll say it backwards a couple times. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36. That was easy, right? Because last time we did the disappearing sequence where we started to take numbers out from you. Today we're going to do something kind of similar to that, but a little different. So let's say it again forwards. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36. Now I know that was way easy, but now we're going to go backwards. That's one that really messes me up. And next time maybe we'll do a disappearing sequence backwards on you. Maybe I'll have to do that just to get you. All right, here we go. 36, 33, 30, 27, 24, 21, 18, 15, 12, 9, 6, 3. Now the reason we do this forward and backwards, it helps with our multiplication and then also our division. But by us saying it, it helps get in our mind the repetition. That's very, very helpful. I said helpful a couple times. You guys are you're gonna go, how many times does Mrs. Gaudette say helpful? All right, so let's say it backwards again. Again, repetition helps us. 36, 33, 30, 27, 24, 21, 18, 15, 12, 9, 6, 3. All right, so we've had a little bit of practice. Now we're going to be doing an activity that is on the Elmo or overhead projector. And with this, we have some strips for you. These strips are our 3s, and I'm going to be asking you questions as we go through, just kind of similar to the sequence, but now you have another thing to think about. So if I start with one strip, we have 3 dots. If I was to add another strip, how many dots would we have? 6. All right. So this is how it's going to go. We're just going to keep adding dots and asking questions. But again, this is a routine, and it's a way for us to practice our multiplication and division facts. All right, so we're going to go forward with this one. What would our next set, if I put another one on there, how much would we have? 9. Very good. If we were to add another one? 12. All right, so I have a question for you. How many groups of 3 do we have here? 4. Now I'm going to trick you up. I like to do that. I like to be tricky a little bit. How many groups of 6 do we have? 2. Did you see the first group? And then the second group? All right. So let's go again. If we were to add another strip, how many would we have? 15. Good job. You guys are really good at this. If I was to add another strip, how much would we have? 18. So really fast, how many groups of 3 do we have? We have 6. How many groups of 6 do we have? We only have those 3 groups. But how many do we have in all? How many dots do we have? 18. So 3 groups of 6 and 6 groups of 3 gets us that 18. All right, if I was to add another strip, how much would we have? 21. All right, and if I was to have another strip, how many would we have? Let's check your answer. Were you right? Did you say 24? Did you check? All right, so how many groups of 3 do we have? 8. How many groups of 6 do I have? 4. How many dots do I have all together? 24. Now I'm going to add another strip. Can you already guess what the next one will be? 27. Good job. What will the next one be? 30. So let's think, how many groups of 3 do we have? 10. You notice I had to count there really fast. I'm starting to get off on my own. We had 10 groups. How many groups of 6 did we have? We had 5. 3 groups of 10, 6 groups of 5. How many dots did we have altogether? 30. All right, so let's add in another one. How much would that be? 33. I was nice to you. I gave it to you before I allowed you to give me my answer. So we had 33. How many groups of 3 do we have here? We have 11. Yeah. So let's add one more. What do we have there? We have 36. So how many groups of 3 do we have? 12. How many groups of 6 do we have? 6. And how many dots altogether? 36. So now we're going to take this backwards. That's why we practice that sequence backwards. And you may hear me pause also, because just like you, sometimes I need to double check in what I think is my answer, and that's okay. Remember, math is not about being fast. Math is about, are you efficient and accurate when you're giving your answers. So if I was to start here, how much do we have? We have 36. Good. If I was to take 1 away, what would we have? 33. All right, you guys seen how we're going to do this one? All right, let's take another one away. What would we have? 30. How many groups of 3 do I have? 10. How many groups of 6 do I have? 5. And how many dots do I have altogether? 30. All right, if I was to take 1 more away, what would I have? 27. If I was to take another 1 away, how many would I have? 24. And you can guess it. How many groups of 3? 8. How many groups of 6? 4. All right. And how many do we have altogether? 24. So if I was to take another 1 away, how many would I have? 21. If I was to take another 1 away, double checking my math now, 18. Yep, see, it's okay. You guys saw me yesterday where Miss Sears helped me with my math. So now, you guessed it, how many groups of 3 do I have? 6. How many groups of 6 do I have? 3. How many dots do I have altogether? 18. If I was to take another one away, how many would I have? 15. If I was to take another one away, I would have 12. How many groups of 3? 4. How many groups of 6? 2. All right, now I'm going to tweak it up just a little bit. What happens if I took 2 strips away? If I was to take 2 strips away, I would have, you guessed it, I would have the 6. So how many groups of 6 do I have? 1. How many groups of 3? 2. How many do I have all together? How many dots do I have all together? 6. So if I was to take 1 more strip away, what would I have? I would have 3. If I was to take another strip away, how many would I have? 0. Very good. Thank you guys for participating in this with these are called Untiles, with the Untiles with me. Again, remember practicing this activity, doing your sequences forwards and back, being able to practice forward and back will help you with your multiplication and division. This is a fun activity to do where your parents or adults could ask you those questions. What would the next one be? And you can give that answer to them so you can practice it. All right, so Mrs. Sears is coming on, and she is going to go ahead and move into a task with you. And we are trying to make sure that we have that up.
There we go. Okay. All right, hello, mathematicians. I'm Mrs. Sears, and we are going to be doing a problem-solving task with you. So if you did have a piece of paper, a pencil, and you want to go ahead and write this task down, let me go ahead and add it up here on the screen. You can do that as well. You can also be keeping this in a spiral notebook or a composition book, so you can refer back to the different things that we're going to be doing as we move along through the programming. I want to remind you, and maybe Mrs. Gaudette can also go get the vocabulary sheet, because I am going to be talking about some vocabulary today. But one of the strategies, which is kind of a way to solve the problem, is to think about it as searching the word problem for clues. We're going to translate those words into an equation. Then we're also going to answer the problem, but we want to make sure we're precise and use that vocabulary that we need to use within the problem. And we're going to review the solution and check for its reasonableness, also its accuracy, okay? So those are just things that you can kind of think about when you're thinking about when you're going to approach or how you're going to approach a word problem of this nature. All right, so let's get into our word problem. Are we ready? Yes, all right. So unpacking books. On Monday, Mrs. Smith, our school's librarian, began unpacking boxes of books that were ordered for the new school year. In the morning, she unpacked 476, I gotta be careful with these ands, and you're gonna catch me, Miss Gaudette catches me all the time. 476, and in the afternoon, she unpacked 363 books. How many books did Miss Smith unpack that day? And I have a little kind of a requirement that I want to see that, we're going to review a little bit about how to do the partial sums method today and also the standard algorithm. So we're going to try and solve this particular problem with the partial sums method. So if you aren't really familiar with it, maybe listen along and I'll kind of walk you through how that's going to work. All right, so remember when we're thinking about a strategy would be a plan of how we're going to approach that problem. All right, we also want to make sure we'll add that onto our vocabulary wall here in just a minute. So on our star, we want to remember to search the word problem for clues. Well, clues could be what are we doing, like the operation that we're going to be performing. Clues could also be like numbers that we're going to need to know. So I want to talk a little bit about the difference between a number and a digit, because we're going to be talking a little bit about digits today, and specifically looking at those digits and where they are located in their place value. So when we say a number is a string of digits. So this 476, I think I need to add on the whiteboard here really quick. Excuse me. Okay, so that 476 is a number because it's a string of digits. The 4, the 7, and the 6 are digits where they are a single numerical representation, a symbolic representation of whatever that is inside that number. So a digit can only be 0 through 9, whereas a number is a string of digits, okay? So we want to make sure we unpack those 476. We also want to make sure we underline the 363 for the books. And when we're talking about how many, we're probably thinking about the operation of addition, right? Okay, and addition, and when we're using partial sums, has to do with we're adding the parts of each of the different addition values within this equation. And we're going to be then adding those sums all together to help us figure out the solution. Okay, so you see the word part inside partial. That means because we're doing parts of all the different sums of all the values that we're going to have inside that problem. All right, so let's get our equation up there, because that was the next step, right? The t for the translated into an equation. So we have 476, and we have 300 plus 363, right? And we're trying to figure out what does that equal, okay? When we were doing the partial sums, we're thinking about the parts of that number, okay? So the very first number that we would be looking at, and this is very important with this strategy, is we start on the left, okay? We start at the highest value that we can. So in this case, it's the hundreds. So when we're looking at those digits, those representations of those 0 through 9 digits, so we have a 4 and a 3 as a digit there, but that 4, as we know, really means 400, and we're adding that same digit to that sum to figure out that part of that sum, that 300, to help us figure out what maybe the answer is going to be. And I'm going to draw an arrow because I kind of want to try and get you a representation where this is lining up. So we have 400 plus 300 leads to what we know, an answer of 700, right? All right, let's look at those next two. So we have a 7, that's 7 tens, or 70, and a 6, which is 6 we know is the value of the tens, or 60, okay? And that's going to mean something different when we do the other way. That we know leads to, if I was counting up by tens from that 70, and I went 70, 80, 90, 100, 110, 120, 130, and I would put that over here. Now we have the sum of the last one. Again, we're moving to the right. This goes left to right. The other one, we're going to go right to left. So 6 plus 3 is our ones. That's how many? That's 9, right? All right. So now that I've got a representation of how those sums are working, I'm going to continue to add this across going left to right. All right. So if I'm looking at this, and maybe I can, let me see if I can move this up a little bit. Don't know. Nope, it's not going to let me. Ugh. But we have a 700. Oops, and I turned it off, didn't I? We have a 700 plus the 130 plus the 9 equals something, right? Well, for me, it's still kind of a little bit, even though I have that 130, I'd like to break that down a little bit more. I'd like to make that 130 instead, to make it easier in the math. And again, this is just my own personal way of doing it. You might have been able to just do 700 plus 130. and you knew that. But I like to say 700 plus 100, which is really 800, right? And then plus 30 more, 830, plus 9 more equals 839. All right, we've answered that question, but again, we want to be very precise. 839 what? Books. So we want to make sure we add that in there and do that correctly. Okay, so, and I'm wondering, now I have to turn that off, and I think I can then now move it over to the next one. Exit out. All right. Now let's see if I can do that. Okay. So we have another problem. That was the partial sums method. Now we're going to move into our standard algorithm. All right, so on this particular one, maybe, is there a way to move that down? On Tuesday, I know you can't see that very well. I'm sorry, I didn't give you enough time to, let me just turn it off for just a second. Yeah. On Tuesday, Miss Smith continued to unpack more boxes. In the morning, she unpacked 448 books. 448 books, I'm gonna do it, I'm gonna catch myself. And in the afternoon, she unpacked 671. How many books did Miss Smith unpack all together? Okay, it's worded a little bit differently. Solve using the standard algorithm. All right, so we wanna go in, again, highlight those numbers. And those are those string of digits that we were talking about. And we also want to know, what are we doing? We're trying to figure out that how many books. That's going to tell us the operation. Addition, right? How many? We're trying to figure out how many altogether. Altogether is another word that kind of leads you to know it might be addition. So let's go ahead and set up the problem. Pay attention to the way this one is set up, because it's going to be a little different than what we've already seen. So in this case, we line up each of the numbers vertically, okay? That means up and down, if you were wondering. So I'm gonna do 448, and then we had what, 671. We're lining them up vertically according to their place value, okay? Remember the other one, we kind of like went around horizontally, and we moved left to right. In this one, we're gonna move right to left, okay? So we're gonna pay particular attention to the different columns. And for me, if you wanna go ahead and do this, this does help me in terms of lining it up. And I've sometimes used graph paper so that I can have each little space in there to help me with that. If it helps you to put the lines there so that you know you stay within those columns, that's a perfect solution. All right, so again, we're starting right to left, different from the other one. We're gonna start with our ones. We have 8 ones and 1 1, 9, right? And we put that representation inside that place value. We can only have one digit in there to represent that section. That's gonna become very important in this next step, because what do we notice? We have 4 and 7, like that's 11, but 11 what? It's 11 tens. I can't put an 11 in here. There's not enough space. We can only allow one digit to represent that. So when we think about having that 11, that's 11 tens, we can regroup. Regroup, it just means that we're going to be rearranging them according to their place value. We know that 10 tens equals 100, right? Another way to represent that might be 10 times 10 equals 100, and I think I missed a 0 up there. So we're gonna regroup 10 of those 10s into 100, but if we do that, we need to remind ourselves, where do we put that 100? Well, we've gotta line it up in the right place. We've gotta line it up in the hundreds part, right? So we gotta make sure we account for that. So we did say we had 110, right? So what would remain inside that section of the tens in that column? The 10, right? Because we've regrouped the 100 to be over here in the hundreds, and now we have 10 that was left over from there. the 0 went away. The 0 is just kind of added in there, and if you add a 0 to anything, it's just going to stay that same number. All right, let's go over here to our hundreds now. Remember, we added that 100 from when we regrouped it. We have 100, 400, and 600. Okay, or if you're just looking at the digits, you would add 1 plus 4 plus 6, right? So that's 11 again. Wow, I have all these 11s. Okay, so what happens when I have 11 hundreds? I think you're thinking the same thing. We know we can regroup 10 of those, right? So 10 100s are how many? Oops, I don't think I get the right on that one. How many of you think are 10 100s? So that's 10 times 100. Oop, I'm gonna give you some answers here. I don't want to erase the whole thing, I just want to erase that little section there. 10 times 100 would be 1,000. All right, so where am I going to have to regroup that 1,000? To the thousands column, and you know, I don't think I added it before, but I probably should add a thousands column to my information. So I'm going to put that regrouped 100s, those 10 100s, into the 1,000. And now how many thousands do I have? Or how many hundreds did I have left over? I had that 100 left over, right? Because there was 11. And I have 1,000 plus 0. Or 1 plus 0 is just going to be 1. So how many books, maybe I'll make these a little bit more distinct because they kind of look like the lines that I drew them on. How many books did Miss Smith unpack that day? Let's say it. 1,000, I'm going to write it differently, 119 books. Okay, so we talked a lot about different vocabulary in there. I just kind of want to go back and refresh and say, you know, which ones were we really thinking about? We were thinking about 2 different strategies. And we were also thinking about regrouping, talking about digits, and talking about those numbers. All right, I'm going to get rid of this one. We're going to move to the next one. Let's try this, see if it works better. And we're going to compare those 2 strategies, okay? So this is kind of important. So let's think about that. In the partial sums, we added all the sums of all the parts. So you see all the parts here, right? We had the digits that represented them. We had those values in there, the 400 plus the 300, the 70 plus the 60, and the 6 plus the 3. And then when we kept adding, we kept moving from left to right. So that we would then add those numbers, the 700 added to the 130, to the 9 to give us 839. Now, as I said, for me, it was just easier for me to break up that 130 so that I can easily add those numbers across. So kind of in reviewing that, we want to add the sums of all the parts, start on the left from the largest place value and move right, adding all the sums of each of the place value. Standard algorithm, little different. We lined up each one of them vertically, meaning up and down, by matching their place value, starting with the ones, and then we moved right to left. So we're not going this way, we're going this way. Okay, that's a little tricky. Add the numbers that share the same value, those were in each of the columns, and then regroup if necessary. All right, so that was a little bit of how to do that one. I have one more for you to try at home, and remember, these resources are there for you. So if you have an opportunity, please go to those resources, and I want you to try it, because in this particular one, you could choose either the partial sums method or the standard algorithm to help you solve your problem. All right, I'm gonna let Miss Gaudette come around and read a book to you. Thanks, guys.
All right, everyone. So we are gonna move into a reading of our book. I love to do this because I always get to have fun with the books. So we are going to be reading The 512 Ants on Sullivan Street by Carol A. Lossie, illustrated by Patrick Merrill, Math Activities by Marilyn Burns, and it's published by Scholastic.
I'm just going to write these vocabulary words up here real quick.
All right, this is the basket with goodies to eat that we packed for a picnic on Sullivan Street. This is one ant who carried a crumb from the basket with goodies to eat that we packed for a picnic on Sullivan Street. These are two ants with some pieces of plum. They followed one ant who carried a crumb from the basket with goodies to eat that we packed for a picnic on Sullivan Street. Wow, these are some hungry ants. There go 4 ants with a barbecue chip. They held it above them so they wouldn't trip. They trailed the 2 ants with some pieces of plum, who followed one ant who carried a crumb from the basket with goodies to eat that we packed for a picnic on Sullivan Street. Here come 8 ants with a crisp bacon strip. They chased the 4 ants with a barbecue chip, who trailed the 2 ants with some pieces of plum, who followed one ant who carried a crumb from the basket with goodies to eat that we packed for a picnic on Sullivan Street. Now, 16 ants took a hard-boiled egg. They rolled it along with a kick from each leg. They followed 8 ants with a crisp bacon strip, who chased the 4 ants with a barbecue chip, who trailed the 2 ants with some pieces of plum, who followed one ant who carried a crumb from the basket with goodies to eat that we packed for a picnic on Sullivan Street. The 32 ants hauled a wing and a leg. They trailed 16 ants with a hard-boiled egg, who followed 8 ants with a crisp bacon strip, who chased the 4 ants with a barbecue chip, who trailed the 2 ants with some pieces of plum, who followed one ant who carried a crumb from the basket with goodies to eat that we packed for a picnic on Sullivan Street. These 64 ants spied some takeout Chinese. They carried the white paper carton with ease. Whoa, did you see that one? They chased the 32 with a wing and a leg, who trailed the 16 with a hard-boiled egg, who followed the 8 with a crisp bacon strip, who chased the 4 ants with a barbecue chip, who trailed the 2 ants with some pieces of plum, who followed one ant who carried a crumb from the basket with goodies to eat that we packed for a picnic on Sullivan Street. Now, 128 ants grabbed some cheese and trailed the 64 with the takeout Chinese, who chased the 32 with a wing and a leg, who trailed the 16 with a hard-boiled egg, who followed 8 ants with a crisp bacon strip, who chased the 4 ants with a barbecue chip, who trailed the 2 ants with some pieces of plum, who followed one ant who carried a crumb from the basket with goodies to eat that we packed for a picnic on Sullivan Street. Then 256 ants yelled, "Hooray!" They spotted a fudge-covered cake on a tray. They pulled it and pushed it, but all of that fudge made the cake much too heavy. It just wouldn't budge. Taking the cake was such a chore that those 256 doubled once more. Then 512 ants, all ready to dine, picked up the cake and got right in line. They followed the 120 ants with some cheese, who trailed the 64 ants with takeout Chinese, who chased 32 ants with a wing and a leg, who trailed 16 ants with a hard-boiled egg, who followed 8 ants with a crisp bacon strip, who chased the 4 ants with a barbecue chip, who trailed the 2 ants with some pieces of plum, who followed the 1 ant who carried a crumb from the basket with goodies to eat that we packed for a picnic on Sullivan Street. By the time we were hungry and ready for lunch, all our goodies were gone. There was nothing to munch. But the ants had a picnic with goodies to eat down in their ant hole on Sullivan Street. All right, so let's think about this and the numbers that we had. So we started off with the 1 ant who had a crumb, then the 2 ants that had pieces of a plum. Then we went to the 4 ants with the barbecue chip. Then we went to the 8 ants with the bacon strip. Then we had 16 ants with a hard-boiled egg. Then we had the 32 ants with what? Do you remember? The wing and a leg. So let's be thinking about that. Did you notice a pattern that was happening? Did you see that? Ooh. Let me erase all. So did you see that, that pattern? We started with 1, then went to 2, then we went to 4, then we went to the 8, 16, 32. Did anybody notice what that pattern was? Right, we could have doubled the 1. I could have doubled, like with 1 plus 1 equals 2. 2 plus 2 equals 4. What else could I have done? I could have multiplied by 2. I could have done 2 times 1 equals 2. 2 times 2 equals 4. Now, I'm one of those ones where I really feel like I need to know what the rest of the sequence was, because I want to double check their work. I want to make sure that does this doubling and multiplying by 2 work? So what was the next number after 32? It was 64. What was the next number? 128. Hopefully someone's checking my math with me to make sure I'm doing this. What's next? 256.
And I would just make sure that we're saying 128.
Oh, did I put my and in there?
You didn't say and, but you didn't
I said
claim you didn't claim really the digit. You say 128. That's really 100.
128. Thank you, Miss Sears. 256. And then our last one was it? Yeah, we had our 512. Thank you, Miss Sears. All right, so I'm going to double check with my doubling method and see if this is true. So if I did my doubling, I would take my answer. 4 plus 4 is 16. Yes, that did work with my answer there. 16 plus 16 equals 32. All right, yes, my sequence is working. 32.
Did you miss the 8?
Oh, I'm multiplying, aren't I? All right, we have here 8. See, remember, I said this last time, and I'm going to say it again. Math is about making mistakes. The reason why is we learn more from our mistakes. And sometimes our mistakes are just simple errors. That's okay. But remember, that will probably stick more in my mind than if I had gotten it correct. So remember that, you guys. Just keep at it. 8 plus 8 equals 16. 16 plus 16 equals the 32. Our 32 plus 32, is that equal our 64? It sounds like this is working. 64 plus 64 equals the 128. 128 plus 128, did that give us our 256? Well, I know from Miss Sears, when she did her partial sum method, we had our 100 plus 100 is 200. And our 20 plus 20 would give me 40. Oh, nope, see, this isn't going to work, is it? This one's wrong, so this method is all wrong, right? Ah, you guys caught me there. My 8 plus 8, if I add that, I get 16, which brings it on over to our tens place value. So that is 256. Let's double check with our multiplication. So I'll take my 2, I'm going to multiply it by my last answer of 4, and I get 8. It's still working. And then if I take 2, multiply it by my answer, 2 times 8 is 16. And then if I take 2, multiply it by 16, I get, you're right, 32. So it looks like doubling and multiplying by 2 are 2 patterns that works for us. So my question for you is, if this pattern was to continue, this one right here where we have goes to 512, would I hit 1,000? No, we wouldn't hit 1,000, because if I doubled 512, I already know that it's over 1,000. So that won't work. So here is what I would like to do for you. I would like you to do, actually, is our sequence that we had, our pattern did not equal 1,000. I want you to see if you guys could come up with a pattern that another number that you started with that would be, if you doubled it, would end up for 1,000. So take another number. If you keep doubling it like we did, would you get 1,000? See if you can find a number that would work for.
We're going to need you to stay up here for just a minute, but if you can maybe forward that through so I can get our game board up here. I'll need it to be on the HDMI. But in case we have a backup. All right. So, and you have some markers over there if you need them as well. All right. Thanks for doing that for us. That was really helpful. I kind of learned a different way, and you used my strategy too. So we're going to be playing a game. It is called How Close to 100. This game is actually something that we found on a site called ucubed.org. And it's actually kind of a really fun game, and it's using multiplication. And we're kind of going to be looking at the concept of area within this multiplication, because we're going to be drawing some arrays inside of this grid that is 100 grid. Okay, and how do I know it's 100 grid? Well, I have 10 rows, and I have 10 in each row. And so remember, when I'm thinking about an each kind of is telling me I'm doing multiplication. All right, so we've got the grid up there for you, and it's also available to you on the resources page that we have for APS. Let's explain how this works. And I know,
do you want this now?
I don't know if you're going to be able to see that and that, because otherwise it won't work together, right?
Yeah, it won't work together.
All right.
You want me to switch it?
No, this is okay, because we're going to be writing right on top of that. And maybe I'll use my finger or you can use the pen, however you want to do it. We'll decide. We can do Rochambeau again. Rock, paper, scissors. You're going to need 2 dice. You're going to need a recording sheet, or you can make a recording sheet of your own. I did that when we were at a much lower tech option before. You're going to need these 2 dice, and what's going to happen is when you roll these 2 dice, you can play with one partner on one grid, or if we wanted to, I could be playing on this grid and she could be playing on that grid. You can play on separate grids and see how close either one of you gets to the 100 and kind of work on that. But I'm going to go ahead and roll the dice, and so when I roll the dice and I got a 6 and a 4, I would take, and I'm going to demonstrate it on mine, I would take that 6 and 4 and I'd have to configure an array. So I'd have to know I'd either go 6 rows or do 6 columns and move down. It just depends on however many I want to do. So in this case, I want to do 6 times 4. So I want to do 6 rows. So that would be this, 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 this. That's 5, 6 of 4 each. So I'm going to go da, da, da. And that's kind of going to give me like my shape, my general shape. And I'm going to have to color that in. Now, if I didn't know 6 times 4 right away, I could count each of those little mini squares inside there to help me figure it out. I could also maybe skip count by those 4s. I think we did that in the other day. But we could go 4, 8, 12, 16, 20, 24. So that's going to tell me my answer. Then I would write my answer down here on the grid. Okay, 6 times 4 equals 24. All right, so the object of the game is to try and fill up this grid. Now, when Miss Gaudette goes, she may choose to start on a different part of the grid, maybe down here on the bottom or up here on the top. You wouldn't want to start in the middle. What would happen if I started in the middle?
Don't give any hints away. Goodness.
Well, but I'm thinking, that would kind of ruin a whole big space. So you really want to kind of think about when you're working on this, start in your corners and kind of work to help fill in those spaces, okay? And the object of the game is to really be able to fill in the gap. I'm not doing mine and you're not doing yours separately. We're going to be doing it on the same one. So we're working together to try and get how close to 100. It's not a competition.
Well, but then if because I know a game and I have to remember the name of it, but there is a game where you start in your corner and then you make it where they can't do any more.
Can't get anything, yeah. No, this one we're working together. If we were working separately on our grids, it might be a competition, but we're working together on this one. All right, so are you ready to begin? Okay, I'm gonna roll the dice and then I'll speak it to you because again, I don't wanna, ruin the scene that we already have up there so that you can use it. But you got kind of an example of how we got started. All right, you got a 4 and a 2.
All right, so that I know. Am I just putting my answers here or?
You can put your answer right there.
Right here?
Where if you want to start on the 6, it doesn't matter that, we know that's your side and then I have that side. We'll see how many we get to.
So I have a 2 and a 4. So I can either do 2 columns or I can do 2 rows.
Yes.
Okay.
4 each.
Yes.
Yes.
So I'm going to do my, so that's 1, 2, 3, 4. And then I color this in. So that equals 8. And I know it by 2, 4, 6, 8. Also 2 times 4 is 8.
And if you're thinking about that, if she had changed it, just a for instance, if she had changed it to be the 2 rows with 4 each, that would have been like that turnaround fact that you guys might be used to seeing. And all it does is just reorientates the area or the rectangle in a different way. Okay, so you could do it any way, but just realize that your 4 times 2 would be the same as your 2 times 4. It's the same idea, you're just flipping the fact. All right, my turn. I'm gonna use my finger on there, so let's see, we got 3 and 5. Okay, so I've gotta be conscious of where she's at over here. Could I go 5 across? I could go 5 across and still have some space there left in case we need to fill that in. Yes.
All right, I have a question.
Yes.
So if we're working together And we're trying to fill this all up.
Yes.
Wouldn't we want to butt up against each other so
We
that...
could. That might be a different strategy. I don't know.
I'm just wondering.
That's true. We could have something that's right there. And let me do a different color so that you know where I'm at and where you are. So you're thinking maybe if I did the 3 and the 5, that would be a better solution. I like that. See, this is good. We can work together on this. All right, so I'm going to do 3 rows. Oop, don't I need to have a pen? We're going to do 3 rows. Am I still not there? Maybe I need to do super big. 3 rows of 5 rows of 3 each. Okay, so that would be 3, 6, 9, 12, 15. I'm kind of going to try and make that a little bit better. I'll switch it back for you. All right. Oh, thank you. See, she's catching me all the time. So that was 5 rows. Oh, boy, that's a big one. Woo. Now I need to make it thinner, huh? Can I borrow your, let me see if maybe I can just do it that way. 5, nope, doesn't help me. 5.
Is it because, here, let me put it down.
5 rows of 3. That's 15. That's like super big. I know you can't see it, but my finger doesn't go like super thin. Let me see if I did that way. That might help. You can be working on rolling that other dice
so
here
I'm going to roll the dice.
while I'm figuring this out.
I have a 4 and a 4. So I already know that's going to be a square. Because a 4 by 4 is a square. So if I was to do this, I'm just looking at what we have and how Miss Sears is here, where I could not do my 4 and 4 there. That would kind of do it. I would overlap on her, so I'm assuming I'm not allowed to overlap.
No, you're not allowed to overlap on mine.
Okay. So then my next thing is I could do a 4 by 4 here. I could do a 4 by 4 here. My question is if I did it here, I would close that off.
We'd only have to have a 2 by 1 or a 1 by 2. That's the only slot that could, but that's okay because the idea is to get to how close to 100. So worst case, if we only got to 2, I'd be okay with that.
I'm going to go ahead and do that. So I am here.
And notice it is a square.
Hold on. 1, 2, 3, 4.
I was going to say, notice it was a square, and then she fixed it. It looks like a square, right? It's got all the 4 sides are the same.
All right, so I know 4 times 4 is 16, and
Perfect.
that's a square.
Okay, let me see how many more rounds. We might be able to do one more round, but we'll see. I got a 4 and a 1. So
Only had been a 2.
I know, if only it had been a 2, and I would have totally done that. So let's see, 4 times, I'm going to use this space down here at the bottom.
Perfect.
And let's do this. I might need to make it thicker.
No. Now that I'm not using the pen, I think you're fine.
Oh, now that you're not using the pen? Oh, okay, perfect. I'm going to leave it there on that one. Okay, so we had, what did I say, 4 times 1? This is 1 row of 4. So I need to make sure I have that 1. I have 1 group of 4. All right. Whoa, there we go. And finish my equation. Go ahead.
All right. So 5 times 6. So if I was to do 5 times 6.
2 4.
5 times 6. So I guess I need to ask you a question, Miss Sears, because you keep saying a certain orientation of the box based upon the way you're saying it. So help me out there.
So you need to have 5 rows with 6 in each row.
Because of the way I wrote the equation.
Yes.
Okay, that is good to know. So I would do 1, 2, 3, 4, 5. Nope, that won't work. Can I do 6 by 5?
You
1,
can.
2, 3, 4, 5. 2, 4, 6.
All right.
All right.
I know that we're coming close on our time, so we're going to finish it right there. We didn't quite get all the way to the 100 grid, but we did a really good job of closing in those spaces. So we did today a lot of different things. We had a lot of fun with, again, those sequences that we were working with. Learned 2 different strategies for how to solve a problem, the partial sums method and the standard algorithm. Read a cute little book,
I know, that was so
512
cute.
Ants, and finished it up with a really, really fun game on U cubed. So we want to say thank you for joining us today at Home with APS. Bye-bye, mathematicians.
Have a great day. Bye.